started the Lytro Emerge project and act as an architect and currently focus on the computer vision and machine learning side of it.
Your role and
Yeah, I'm a director of engineering on the VR side. My teams work on the two ends of our system, the capture system, the camera software, as well as the final playback and compression into headset.
So I want to tee you guys up to talk about kind of where Lytro sits in the value chain. We heard from those guys earlier in terms of introductions. We heard from Steve that sits a lot on kind of the display side. When we're talking about light fields, there are many kind of parts of that. There are many parts of that value chain. Where does Lytro kind of begin and end within that value chain in terms of being on the capture side and capturing, for different types of video? Where do you guys specialize? You've been with the company since the beginning. So, what's the kind of philosophy and the kind of design principles behind Lytro as a company and what you guys are doing?
Sure, so I guess I'll take this. We've been bringing very new technology to kind of the world since the beginning. And one of the things we've had to do is build an end-to-end pipelines. So whether that was our initial consumer cameras or the Lytro VR, we are capture to playback and every piece in between.
So I think that, also to kind of give some perspective to the audience may kind of know Lytro in lots of different ways. And this kind of historical exercise, I think puts it into perspective. A lot of the early days of Lytro was all about kind of refocusing cameras. And going back to the principle these guys talked about earlier in what Ryan was saying, kind of capturing all the light in a given space, to then be able to have a lot of different perspective, be able to do a lot of things in post-production. A lot of those principles applied in early days to kind of refocusing, capturing all of that light to be able to do things like different focal points and different aperture after the fact. And that has evolved in lots of ways, such as kind of a prosumer kind of version of that principle, moving on to a really kind of high-end cinematic version of that for directors to do that same principle and then do a lot in post-production, make a lot of decisions as if they were on set. And then moving on to, as you mentioned, Emerge, to be able to kind of bring those principles yet a step further in terms of 360 capture and kind of volumetric movement. And then, of course, this kind of lens array beast we just saw in that video. So I guess where
that is the Emerge.
Oh, it is. Okay, so it is. Yes. So I guess where this all is going is, what can you say about this continuum in terms of where you guys are kind of seeing, just judging from your past trajectory, looking forward, and what you guys are kind of working on now that is making you excited?
Sure, I guess I can start here. So to give a little bit of history on the company, we initially came out with two versions of the consumer product. The top left one was our initial camera. And then a couple years later, we came out with the Lytro Lume. And I want to give a shout out to the fellow who is shooting with the Lytro Lume, because that's awesome. But one of the things we learned going through the exercise of building consumer cameras is there's a hell of a lot of trade-offs you have to make. You have to deal, there's very high price pressures, there is limited hardware availability, and you have to choose a lot of commodity hardware. So, looking back, one of the things that was toughest about our consumer products is the set of trade-offs we had to make. So a few years ago, we went through this pivot where we really focused on, all right, how do we bring the best possible light field experience and all the promise of light field without some of these trade-offs? So we went decidedly upmarket with Lytro Cinema, which you don't quite see the scale of that thing, but it's enormous. And it's nearly a gigapixel sensor that runs at 300 frames a second to kind of give you a little sense of scale. And the purpose of that one is, how do you bring the promise of light field to cinema capture? So light field input, but it's still a traditional two-dimensional output. And with the Lytro Emerge, the goal was, how do we deliver true immersion with real-world data, which is something no one's been able to deliver. And the only way to really do that is to make a massive light field capture device. And that's what we've done with Lytro Emerge.
It's also a great business model, because would the light field capture be better with the incentive to buy more of them? Possibly.
Yeah.
I won't make you answer that. So moving on, one thing that I find interesting is that we're hearing a lot, maybe it's just selective memory, but we're hearing a lot more about light fields, and I think that's probably correlated to the more recent interest in immersive technologies like VR and AR over the last 2 years. So, building on everything that you just presented there, what are, Alex, I want to bring you in here. What are some of the challenges you see in terms of what the marketplace is kind of eager to get and what you guys are delivering with light field technology, and the distance between those 2 points and the kind of challenges that you guys are faced with?
Yeah, I mean, on the technical side, I mean, to implement this very real kind of experience in VR using light field, the sheer amount of data is just a real. You're trying to capture all the rays of light that's in some space. So I think if you look at our technology pipe of capture, post-process, and then playback, on the front two, you can kind of solve that with a huge amount of computing power. But the real challenge comes in the playback, because the headsets have to be driven from a single place, from a single PC, and just cramming all that, all of that kind of volumetric, rich kind of amount of information, and then having that work in real time is very, very challenging. And I think on the marketplace, in terms of the word light field being used a lot, I think that there are a couple of things. So I think the promise of light field is that you get this real experience, that you have parallax, and all the lighting is real, and that's what the promise is. And I think to be technically light field, you can kind of say, oh, I can capture a little more data and call myself, I'm technically doing light field, but you don't quite get up to that promise.
Now, a lot of technologies are held back by or assisted by things like Moore's Law, where things get smaller and cheaper over time. Is that something that doesn't apply here? Because in some ways it would seem that you need this kind of diameter of lens array in terms of like a function of the amount of parallax you're getting. Or is that wrong? I mean, is this something that would be confined by things like size?
I think it's a mix, frankly. So when you're talking about the volume, so one of the terms we use is the light field volume. So when we're playing back, the amount of space you can move around in that experience is really guided by the size of the rig. Yeah. If you didn't capture light rays in a certain area, you can't accurately recreate them. You may be able to interpolate, you may be able to guess, but it's not real. So you're never going to get around this size constraint. But what you do get out of kind of the technological march forward is the things like Alex is talking about. Can we shove more data, increase the quality? I'm also going to talk like on the algorithmic side. There is huge strides being made these days in machine learning and neural networks, and that's one thing I'm working on pretty heavily right now. And how does that affect our rig? There are a lot of ways that could affect our rig, making it actually a little bit simpler. So it's not necessarily Moore's Law, but it's just the march of technology.
Now, how much of it is also compression? And bringing back in Ryan, Ryan's company Visby works on compression, and the way he's described it to me in the past is that with this kind of lens array, you inherently get a lot of redundancy. I mean, it's a lot of data that you need, but some that you don't, and just the more clever, efficient uses of that data can help you with that data challenge that you mentioned, Alex. Would you say that's fair?
Yeah, I mean, like, compression's a must. I mean, without compression, we can't even push the data through the CPU and GPU. Mm-hmm. But the challenge we have in volumetric playback that a lot of existing kind of codecs don't suffer from is we need to support what we call spatial random kind of spatial random access, which means you don't know where the viewer is going to be next, right? So which means I cannot always compress the redundancies in a way that could be performant in playback. So again, as Moore's Law kind of pushes forward, that'll be a huge help.
Sure. Yeah, and I'll just add one more point to that. It's not just always a matter of Moore's Law, too. It's also what do you convince the hardware manufacturers, what algorithms do you convince them to put into hardware? So as light fields and light field delivery becomes more common, and our algorithms for kind of decoding and encoding, or for that matter, Visby's algorithms for encoding and decoding become more standardized, the moment those algorithms get put into hardware, a hell of a lot becomes more feasible.
That makes sense. Now let's talk about some of the use cases. We saw this beautiful video, and that's kind of a lean back experience in terms of produced content. What are some of the other areas you guys feel are underserved or that you're aiming for light field technology to enhance or to create, whether it be entertainment, whether it be practical, whether it be enterprise, anything else that you guys are kind of looking at as that's kind of currently underserved?
I think in the entertainment category, it's a whole lot of funding for it now. And I think one application where VR could have a profound change is how people learn, right? You could go someplace, imagine a kid finding a class very, very boring, and then you can actually show them what things look like in headset. I think that would be a great application for it. I think just the lack of funding is kind of making it not an active area right now.
Now, in the absence of light field, put light field aside for a second, I think what people are most familiar with when we talk about kind of volumetric movement is a polygon approach and something graphics that was built in a game engine, and that has some advantages in interactivity. Now, of course, light fields have great advantage in terms of accuracy, beauty, accurate light, and all that stuff. Do you guys see them kind of coexisting or existing in kind of different use cases?
I think the answer is we absolutely see them coexisting. It's a little bit trickier to manipulate light field data in real time, but combining the two is absolutely on the table.
Yeah. So in the last probably 6 months or so, we've seen kind of a shift in attention of the excitement and funding and all the things happening around VR shift a lot to AR, largely driven by the larger installed base of smartphones out there with the topic of mobile AR. We saw Apple's announcement yesterday. We could talk for a while about that. We can circle back to our feelings on that. But the question really is, generally speaking, where do light fields fit in, if at all, to kind of mobile AR? We heard Steve absolutely talk about it in that context in terms of how graphical overlays fit into this discussion. But how are you guys seeing that?
Yeah, I mean, so AR and VR in terms of the capture, the post-process, and then the data, they're actually quite common. I mean, they're quite similar in many ways. If you look at how we consume content now, we consume it on a bunch of rectangle screens. That's very, very flat. It's your phone, it's your TV. For both VR and AR, you're really experiencing things in a volumetric way. So Lytro's tech is really about getting data from onset to headset, and then we're really agnostic to what kind of headset that it is, and then the way we view AR and VR is just one more headset that we can support.
Yeah, and maybe just give the very simplest example, like the Hallelujah production is fully immersive, it's meant for VR. But if we have that singer, put him on a green screen, just pull that off, we have a light field asset you can put in AR. It's kind of, like Alex said, it's very interchangeable.
So to the extent that you guys can talk about it without too much kind of forward-looking proprietary stuff, where are you guys kind of moving next and most excited about? Not only what you guys are working on internally, but how that aligns with where you see technology trends going, such as what you're enabled by in the march of Moore's Law, and to bring that up again, where are you guys excited to move next?
I mean, one of the challenges in the VR kind of space right now is if you look at how content is produced, and then the cost of that, and then how it's consumed, and how consumers pay for it. Some of the business side is not solved yet, as in people think it's fun. Are people really paying, to buy film, to watch in headset? And is the problem because the content's not there yet, or is because there's not enough headsets for the funding to be there? I think that's still kind of being figured out. So what we're really excited about is in terms of location-based entertainment, where you go to a trade show or you go to a place and you can have installations and you pay for a ticket and experience stuff. That model is starting to happen now, and we are seeing that. And then the way we kind of position ourselves is we are on the higher end of that. So I think we'll continue to kind of push the bounds there. And I think on the kind of the mobile kind of based headsets and things like that. So I think as the business model there matures, we'll definitely want to work on that area as well.
And just to add a little bit more color commentary, like when you have a light field, you have essentially the top quality piece of data you can have. So when it comes to mobile, you can kind of down render that. You can get omnistereo. You can get 3D assets. We can generate all of those things from the light field. So, and you know, if the device is less capable, we can deliver it in that. So it's kind of, a light field is really a mastering format.
Interesting. And back to what you were saying, Alex, the kind of classic chicken and egg challenge. You know, there aren't enough of an installed base in owned hardware to motivate content creators to create content, and then that also works in the other direction in terms of buyers kind of justifying that big purchase when there's not enough content out there. So I think that's a very astute thought that in the meantime we're starting to see some kind of pickup where it's almost, you could think of it as rented or temporal experiences rather than ownership. And I think that we're going to slowly see that chipped away and prices come down and getting there. So I think what we're going to do soon is take some audience questions for you guys. We also want to give Steve and Ryan the chance to come up and kind of be part of the audience question portion. But Emily, I believe you wanted to say something first. You'll do that after? Okay, sure. So I will, I guess, walk around with this mic. Looks like we have a lot of questions for you guys. You first, gentlemen. Then you and then.
So how scalable is it for people? You create a master track of your content, but then you want to scale it down to ARKit or ARCore or Gear VR, or like how easy is it for developers to scale it down? And then, you know, how do you work with different kinds of displays, like light field displays, and is this is this going to be accessible to? Like, is this like for like a really big content studio? For, are you creating something for the small developer, small video developer?
Oh, sure.
So I think like VR is just so young. I mean, we just have the first generation of headsets, and I think we are kind of spoiled by our 4K 10-bit at home. Your home experience now, and then the theater experience isn't all that. The delta is quite small now. But remember, once upon a time, your home was really shitty, right? You had VHS, you have NTSC and all of that. So I think VR is probably modeling after that, as in you have the theater now, which is the in-venue stuff that you can experience amazing things, and then your home is probably going to be shitty for a little while. And then as tech kind of goes forward and as we invent more stuff, that gap will close again.
You guys want to add to that, or know about this gentleman's question?
I actually missed the initial question, but I just want to quote Alex Song: "Your home is shitty, and it's going to be shitty for a while." That's a straight up Lytro quote right there. Actually, so a little counterpoint. Everything you said is right, but I'd also like to point out that the headsets are being really held back by the current software stack, right? If you get a light field playing back in like today's hardware, you'd realize they're actually pretty high resolution relative to most of the stuff you can see. They're actually decent. It's just that like you're looking at a video game, or you're looking at a 360 video where the pixels are stretched out really huge. So we haven't actually like found the ceiling for the current hardware, but by the time we do, the hardware will be better and it'll be beautiful, and you won't live in shit anymore. It'll be really nice.
You guys, I'm curious about the rendering side. You guys said that it's not polygons. Is it something like a distance field kind of shader thing, like 2 polygons, and then you kind of merge all the data into, from the point of view of whatever the guy is looking at?
The closest thing would be depth image-based rendering. So we have RGB in depth for a large number of viewpoints, and we interpolate that on the fly.
But that's like on a shader.
Yes.
Okay.
Question, sir?
So my question is, have you guys explored using your Lytro camera as a static, like, photogrammetry capture device for virtual reality scenes? And have you explored using newer technologies like Google Seurat or the Otoy pre-rendering pipeline in order to be able to render your super high quality 3D scenes in real time as like static geometry inside of virtual reality experiences?
No comment. Stay tuned.
Okay. Thank you. So, okay, that was really short, and then I was shorted. Okay, quick question. Today's topic is live field and volumetric VR. You keep talking about live field. Can you guys give us like a very light explanation? What's the difference between these two? I'm sitting here. Yeah.
I want to volunteer myself for that one. When we say volumetric, I think we're really talking about 2 fundamental approaches that are already in market. in various ways, or really at trade shows, I guess. One is the standard polygon approach, which is exactly ripped from a video game, right? So the image you're looking at is a series of polygon meshes with textures wrapped around them, and then you can use a standard video game stack. It might literally be running in Unity or Unreal or something to like calculate the perspective you would see on the fly. 30 games of 3D video game engineering behind it. It's a very mature stack. It's very good. It looks like a video game. The other one that's really similar that gets lumped in with volumetric, I think appropriately, is point clouds. And there's a lot of advantages people talk about over point clouds over with sort of polygon-based approach. But in a very short version, a point cloud approach says, let's actually kind of say scan the real world into a series of discrete dots. You can later stitch them together on the fly into something like a mesh, but in practice you're actually keeping all these point samples separate from one another. Functionally it's different under the hood. In practice it's a riff on the same idea, that the world is a 3D shape, and that 3D shape has a fixed color, and then you're going to calculate your perspective on the fly. The reason I think we're all excited about light fields is that there's this promise that as you move around, you're not restricting a surface to a single color, right? You can have reflections that move around them. You can have little glints and flickers. You can have things that aren't well represented by polygons, puff of smoke, someone's hair, right? It's just like kind of more higher fidelity in theory, right? So the gap between the two is volumetric's here today in many forms, good and bad, but it's got a fixed ceiling, and light fields I think has more promise, but there's a lot more work to be done. Is that fair?
Does Lytro have your own like file format where it's like point clouds and you can drop it into Unity or Unreal Engine and people can interact with your point clouds?
Also, stay tuned.
Hey, I'm sure I speak for quite a few people in the audience where we really appreciate that you're fighting on these brave fronts, trying to push the technology forward. So first of all, thank you very much. Second of all, I want to ask if you're positioning this as a distinct experience where my home is shitty, and this is an experience that I want to go have, and I do want to have it, and I want to pay for it. As someone who is still stinging from the Betamax versus VHS battle, back in the 80s, I still have my copy of Powell Peralta's, the Quest of Animal Chin or whatever it was, a skateboarding video. Going to the cinema is a communal experience. And if I'm going to have a premium experience, we're going to pay money and go see a light field-based piece of entertainment, I want to do that with people. It's an event for me. Do you all have any thoughts or vision on how Lightfield is going to be a communal event, and if so, how? Because right now the communal event of cinema has moved from the theater to the couch, and if I'm going to have an event and I want to go someplace, if it's the Void, I'm a Ghostbuster with my friends and I'm shoulder to shoulder and we're battling ghosts. But if I go see this piece of film and it's 3 minutes or 30 minutes or 3 hours, like, do you all have any thoughts on socially how that's going to take?
So there are a number of VR experience where social is a part of it, where you're doing it with a partner, what it means for Avagant, because since we're looking at mixed reality, is being able to also put other people or to be able to both look at the same thing. So it's a little different than VR because you're not completely closed off. You can share that. But from a VR perspective, I mean, it's going to be the same back end that's going to be able to synchronize, different people and what they're doing and what they're looking at. So, I mean, it's an area of great interest, and in going around to a lot of conferences, there are people that are working on it, and it's definitely going to be the only way that people are going to truly, in a mass way, be able to consume content that would be similar to the theater experience. There's actually a really good report. It's free. I think that it was on, maybe it was Road to VR or something like that. It's Ericsson Labs. It's fairly recent. It's from June of this year, and they did both a qualitative and quantitative survey about VR and what people expected to happen with VR or do with VR in the future. And a lot of people were looking at what it's going to replace from actually going somewhere. And theaters were one of them. Sporting events and concerts were another. So there is this expectation that VR can take them places that they can't go, either for cost reasons or different logistical reasons. But to be able to sell that and make money with it, it's going to be up to how do you make this now social, right? And the theaters that are now not attracting people, they're going to have to figure out how to be able to create a venue that brings people together and allows them still to have a shared experience.
You want more on that? I mean, I kind of can talk about anything, so. I mean, first of all, how dare you talk about business models? That's just like, come on, we're doing tech here. Look, at the lowest possible level, light fields are like a file format, right? They're going to work everywhere, and so the question of like, is VR going to live or not? I hope so, but light fields are still cool. It's like PNG versus SVG. If you can't make money running a theater, it doesn't matter what you're running, right? And that's actually, I think, the bigger question. You say like the cinematic experience moved to the home because that's like the social version of it. Theaters are hurting. Theatrical receipts are down year over year. They're casting about and trying to find the next big thing. And one of the things they're looking at doing is turning into sort of VR arcade experiences. They're not doing that from a position of strength, right? They're doing that because cinemas are hurting badly because our homes are great places to watch movies. Like the person interrupting the movie I at least love, so I won't hate them when they interrupt the movie. I don't know. Yeah. There's no punchline there. Don't own a theater. Don't buy one.
Thank you. So, second questions. Looks like you guys have the 59 cameras there. So eventually, how much more data you are capturing? Can you give us some measurable number?
I think Lytro wants all of the data. That's all of it.
It's like, for example, for 1 minute of the video, how much gigabyte or TB?
On this camera, the raw ingest rate is 30 gigabytes a second. So that's just the raw ingest. And as we go through post-production, it gets blown up and shrunk and all that stuff, and it gets smaller at the end. So as we kind of compress it down, it's a lot.
We're gonna take one more question, unless you guys wanted to add to that.
So sort of adding into that, do you think it will ever get to a point where you'll be able to set up multiple ones of those and have something synchronized live, like at a concert, where you can sort of move within that environment? Theoretically, 10 years down the line.
Theoretically, given enough computing power, it's possible, right? Now, it's just the amount of computing we need is so immense. So, in terms of processing some kind of content that we shot, you're not talking hours, you're talking about days of running jobs in the cloud to kind of bring that down. So yes, I mean, given the advancement of Moore's law and all that stuff, it's technically possible one day.
So we're gonna have to wrap there so that we give all these fine people and you guys the chance to kind of have a few more drinks and mingle, and you guys can ask questions. You guys be around for another 20 minutes. You can.
I'll be hanging out on the street corner after you kick us out.
Nice. You'll have the chance to ask them more questions. So please join me in thanking these gentlemen and also Linda.